Hello there, we're going to look today at bivariate data. Now bivariate data is the kind of thing you saw at GCSE when you were asked to draw scatter graphs, and it's not uncommon to draw scatter graphs that go up like this. And it might be, for instance, you're looking at the height of a tree, a fruit tree, and how much fruit it gives you. You might measure that in the weight of the fruit that you get. And it might be, for instance, little trees give very little by way of fruit, and big trees seem to be giving lots of fruit, and that might seem obvious. And actually, I mean, it might be worth having a read of this. I won't bore you with the details. It might be a little maths joke, but have a look at it and see if it makes sense, perhaps at the end of the video. Anyway, let's have a look at correlation then between two variables, bivariate data. Now, before we get started, I'm just going to make sure you know how to use your Casio ClassWiz. Now, this is a picture of the Casio ClassWiz. I'm picking mine up now. Now, what I want you to do, I've just turned mine on, and I've then pressed menu, and I've then pressed it's 6, and 6 lets me type in some numbers. So if you can type those numbers in, so menu 6, and you have to then press 1 for one variable data. And I'm just going to type these numbers in. So if you can do the same, as you go down, I'm literally typing them in now. Okay, I've got them in. And when you've done that, you then press Option, the Option button. So press that. And again, it's number 3 then, because you want the one variable calculator. And did I press that then? No, I didn't. Typical. Option again. Option 3. And then it come up. And it's come up for me. It says that X bar, now this is the mean. And the mean is 177.125. It says to 3 sig fig, so presumably I'm going to call that 177. I want the standard deviation, which is sigma x on this calculator, and mine says 9.65 if I round it. And then standard deviation, if you square it, it's called the variance. And this calculator is one above it, 93.1. So hopefully you can get the same things too, because it's important that you do, yep, all those work. It's important that you can do them. What is correlation? Well, as I said, you've seen this at GCSE. It's the relationship between two variables, and you're looking to see how they correspond. As a general rule, it says positive correlation means a scatter graph is sloping upwards, a bit like the one I just did. And negative correlation means the scatter graph is going downwards. And I think you probably see that. But the only difference is at A level, it's no good just saying positive or negative, or even strong positive. We try to put a number to it. So the number called the coefficient, or the correlation coefficient, goes from 1 to -1. And here's a little picture which I've drawn, which basically gives you an idea. So anything really strong. So if I was to draw a scatter diagram, and it looks like this, and it's almost in a perfect straight line. Now, that looks pretty much in a perfect straight line to me. Now, if it was exactly perfect, it would be exactly 1. But this one, I'm going to say R. Now, notice I'm using the right letter now. R equals 0.9. If it goes downwards, now goes downwards in a straight line. Now it's not this minus 0.81 figure which I'm trying to replicate. It doesn't seem as if it's in a perfect straight line, but it's pretty good. And you can see almost there's a line going through it. And very often we draw these lines of best fit, as they're called, through the points. And this that I'm suggesting is minus. R is minus 0.81. And anything in between, well, it could be any, if it's all hickledy-pickledy and there's no obvious pattern, that would be this R equals minus 0.03 kind of thing. Well, it could be anything, but it's very, very low. The closer you are to 0, the less correlation you have. And the letter, as I've already said, is R, and that's the letter we use for correlation. Now, this is a correlation game. It's actually quite good fun. I'd recommend you have a look at it. I'll just bring up the website so you can see that. So here's the website. You can see it's called literally guessthecorrelation.com. And if I click new game, I have to put in a name. So that's my name, honest. Let's see if it has found someone like that before. There you go. Hello, me. I'm going to play a new game. It's only for 1. And the whole idea is I get given a scatter graph and I have to guess correlation, as the game implies. So I'm going to suggest, I don't know what that is, 0.75. And I'll press enter. And some how I fluked exactly the right answer. I'm impressed with myself. Although no, I'm definitely going to get this one, because this is exactly in a straight line. Well, perhaps I didn't get the other one. So anyway, like that one says, well, I'm doing well so far. Oh, much harder. So I'm going to guess this time 0.4. I don't know how good that is. And it said that it was rubbish. I actually lost a life there. It was 0.06. So you get the idea. You play this game, and eventually it's high scores and all the rest. Now, I recommend you play that simply because I think it's good fun. Now, of course, it being good fun is not the point, I suppose. So we are now going to learn how to enter this into our calculator. And what you tend to get given in an exam question is you get a bunch of data. You get told the x values, which you'd normally at GCSE plot along here. You'd normally go across 1.4 and you'd go up 5. So 1.4, you'd plot a point. Now, for GCSE, that's good. You end up with a scatter graph, 2.3 across and 7.1, 5.9 across, 8.6, and 3 across and 8.4. Now that seems to be about there. So you can see, is there a pattern here? Maybe not. I don't know. What we do, we can get this R value that I was talking about just now by entering in our calculator. And you see here it says press menu, and then press you press 6. So I'm going to do it now. Menu. And then press 6. But what you want to now press is number 2. And 2 says y equals a plus bx. So I've done that, and you should come up with some x and y columns now. So I'm going to type these into my x and y columns, 1.4. And then go across when you've got them in. 8.6 and 8.4. So anyway, I've got them in. Now, you'll notice what I have to do now is I now have to press this option button again. So having done all this, it's the same as last time. Press option. And now, this time, we press number 4, which is this. It's got this regression calculation. And then it just gives you the value. And it's dead easy. Mine says R equals, it's actually the bottom of the 3 letters. We can worry about what the A and the B mean later on. 0.786. So it really is very straightforward. There it is, done. So if you get asked what the correlation coefficient is for a bunch of numbers that they tell you, you can literally just type them into your calculator. And that is good enough if they tell you to do it. By the way, you can do this on the Texas TI calculator or the posher Casio calculator if you've got the big posh Casio calculator instead. Sometimes they don't actually give you the numbers, unfortunately. They give you what are called summary statistics. And in that case, we'll see these in a bit. In that case, you'll have to use the formulae. And I haven't told you the formulae yet, but I will do in a bit. Now, this thing that we've just found is sometimes called the product moment correlation coefficient, or even I've seen it called Pearson's product moment correlation coefficient. And sometimes we call this the PMCC. For short, product moment correlation coefficient. Now, I did talk about correlation does not imply causation. Well, it's mentioned in that cartoon at the top of the starting slide. Strong correlation does not necessarily mean there's a causal relationship. Correlation does not imply causation. I'll tell you what this means. So if you look at these, this is a table of values for the number of pirates in the world. And if you look at here, for instance, in some year, in 1820, there was 35,000 pirates, and the temperature in that year was 14.2. Now, actually, I don't care about the year. What I'm going to do is I'm going to plot the pirates against the temperature. And when I plot them, the pirates go down the bottom here. There's my pirates. And the temperature goes up the side. Now, it seems to me there's a pretty good case for saying there's some kind of correlation there. It's definitely going downwards. It's definitely a negative correlation, we'd say. And if you chucked it in your calculator, it'd probably tell you there was a negative correlation. But does that mean that the number of pirates caused the temperature to drop? And if you think about it for only a couple of seconds, you soon realize that's rubbish. So this would imply that their R value is really, really strong. It's minus 0.9. Pirates therefore cause global warming. No, they don't. There's some other factors involved. And this set phrase that we use, and I want you to learn this, that is correlation does not imply causation. Just because two things are correlated does not mean one causes the other one to happen. And we'll see that in a variety of examples. Now look, I'm going to get you to use the menu and press that 6 button and then do the bivariate data. If you remember, when you type this in, you go menu 6, and then you choose number 2, and it comes up with a table. So can you type these in and see what you get for the R value? I'm going to pause the video and give you a chance to do it. Look, I've just paused and I've started again. So I'm going to hopefully hope that you did pause, did type them in, and you got some answers. This is what I've got when I've typed them in. So let's see. I got 0.898. So hopefully when you typed it in, you've also got 0.898. There's 2 more for you to do, exactly the same. I'd suggest you pause your video and type those numbers in, and each time you write down a value for R. So I want a value for R for this one, and a value for R for this one, please. Pause the video now. What did you get? What did you get? So let's see what I got, by the way. I got the first one, 0.417, and the second one looks like negative correlation, minus 0.914. So look, sometimes they're not so kind. Sometimes they give you what are called summary statistics, and therefore we have to use the formulae. Now, these formulae are in the formula book, so it's not something you have to learn, but you need to know where to find them. And the formula is, for finding R, that. Now, you're now thinking, what the hell is this SXY? And what the hell is this SXX and SYY? Well, there's formulae for those too. There they are. SXY equals sigma XY minus sigma X sigma Y over N. Now, you're probably now thinking, well, I don't know what these are either. Well, luckily in the exam, they will tell you what sigma XY is. They will tell you what sigma X is. They will tell you what sigma Y is. Notice this letter, by the way. It's a Greek letter, sigma, which you hopefully have seen before. And they'll tell you what N is. So all of these things can be found. So let's have a look at a question. So in this question, as I said, they've told us loads of summary statistics. Now, to find R, remember the formula is SXY over the square root of SXX SYY, and they're times by each other. So my first job, therefore, is to find SXY. And that is sigma XY minus sigma X, sigma Y over N. So in this case, it's sigma XY is there, 792, minus 29 times 42 over 10. I'm going to quickly type that in, get out the menu one. All right, 792 minus 29 times 42 divided by 10. And I get, as a decimal, 670.2. And I do a similar job. I do SXX, which is sigma X squared minus sigma X squared over N. And that, as you can see, is 397 minus the 29 squared over 10. 397 minus 29 squared divided by 10. And I get 312.9. Lastly, I need to find SYY. SYY is sigma Y squared minus sigma Y squared over N. And what was sigma Y squared? It's up there, 6728 minus sigma Y was 42 squared divided by 10. And this is, type it in, and I get 6551.6. Now, very quickly then, you can find R. R equals the 670.2 divided by 312.9 times by 6551.6, and that's all square rooted. So I'm going to type it in. And I get 0.468. Let's see if that's the same as before I got last time I did it. Load of working out, 0.468. So I'm pleased by that, because at least it agrees with what I've got this time. Now, there's no time to do much more, but that saves me a few questions I can do in class. We will be practicing both chucking them into our calculators and also putting them into these formulae. So which method should you use? Well, here's a great idea basically. If they give you the numbers, type them in. If they don't, use the formula. See you in lesson.